right, hey there, and welcome to your video on topic 7.2, which is on photochemical smog. It covers pages 606 through 609, plus a additional graphic that I put into your notes. Okay, before we get started, it's always a good idea to go ahead and take a look at the course and exam description. And if you need to pause this and take a look at it, if you don't want to open it up yourself, that's fine. But I promise you that any quizzes and tests that I give you, questions are absolutely going to come out of this information here. So make sure that you take a look at all of these specific topics. There's some on that page, and then there are 3 here as well. So make sure that you make note of those before you start. All right, so the first question is, what are the components of industrial smog? Now, I know this says photochemical smog, but really you can't talk about one without the other. And although industrial smog is not specifically referenced by your course and exam description, they do talk about pollutants put out by coal-fired power plants, which is kind of what this is. So I'm kind of lumping it in here so we can spend some time contrasting. So, industrial smog is from burning coal, specifically from burning coal. So it is sulfur dioxide. The suspended droplets of sulfuric acid is a secondary pollutant that happens when SO2 mixes with water in the air. And then the suspended particulates. So back in the day, this is something that could happen when you burn coal in a house with inadequate ventilation. That means maybe you only had a hole in the ceiling instead of a chimney with a flue that would naturally direct the air out of your house in an active fashion. This talks about how these things are formed, and you can see that the picture is right here. And then you can see also that there is sometimes ammonia in the atmosphere, so you do get this reaction happening. And then remember also you have carbon monoxide and carbon dioxide in there. That's really not as crucial as the sulfur compounds, which then form sulfuric acid, which is, not good to breathe. And then that particulate matter. It's like being around somebody who's smoked all day, every day for an entire week in their room, and then you go in and breathe what's left over. Specifically, this is gray. That's going to come up a little bit later on when we start talking about the other kinds of smog. This is largely not an issue anymore because there are safeguards in place in developed countries that keep this from entering the atmosphere, and then also in developed countries you don't use coal for cooking on anymore. So industrial smog now is a largely developing country problem. So remember, the tie-in there is that if you're shown an age structure diagram that's a triangle, which is, I'm sure as you remember, is a developing country triangle, that also means they are more likely to have industrial smog issues there as well. Let's see, why is industrial smog sometimes a rural problem? And I've already identified the primary and secondary components in industrial smog, and then also the color. Why is it a problem? It's like we talked about before in the previous video, right here, wind. You need to know what the concept of upwind and downwind is. When a wind blows this way and the factory is upwind, the direction in which the wind is blowing is downwind. So if you have a rural area here that is downwind from a power plant that doesn't have pollution controls in place, they're the ones that suffer the pollution, especially that sulfuric acid. We will talk about acid rain a little bit later on and why that is a problem. How do you think industrial smog affects human health? Well, duh, you're breathing in sulfuric acid, sulfur dioxide, and particulate matter. It's kind of irritating to your lungs. And then it can lead to, over time again, strokes, heart attacks, lung cancer, and, death. Let's see, what is the general chemical reaction that leads to... Okay, so we've talked all about industrial smog. Let's go ahead and talk about photochemical smog. And I've always thought that this sounds like a little bit like Dr. Seuss. Now, if you've had chemistry and you enjoy the orderly nature of chemistry, which I do, this is going to irritate the bejeebers out of you. because it is not a balanced chemical reaction. It doesn't even have chemical formulas in it. But here's how it works. You have Vox plus NOx plus heat and sunlight form all of this stuff right here. Remember, Vox are volatile organic compounds, so that can be everything from naturally occurring, like eucalyptus leaves, or it can be everything from paint thinners to dry cleaning fluids to gasoline vapors, plus NOx. NOx is a component that comes out the tailpipe of a car when it burns gasoline. And then you have heat and sunlight. This right here tells you something. This happens during the day and more often happens during the warmer months. So understand the significance of that. And again, here's where that ozone comes from. It's specifically and only a secondary pollutant. Okay, these are primary pollutants. These are secondary pollutants. Ground level ozone. Photochemical oxidants mean it is something that does what it does in the presence of sunlight. Oxidants are things that easily react with other stuff. Why is this a problem? Because it means that it's going to be reactions that you may not want to happen. Aldehydes, just go, you don't have to specifically know what those are. There's a specific kind of aldehyde called a peroxacyl aldehydes. We'll get to that in just a second. And other secondary pollutants. So again, I know this is a little sketchy, but you need to understand primary pollutants, secondary pollutants, where these two come from, the implication of what this is, and what these bad boys do. All right, so this is brown. And again, a little bit later on in some supplementary material I have, I'm going to explain why that is a problem. And then, let's see, here is the whole reaction. Are you probably going to have to plot this out? Frankly, I don't know, and especially since it's open note, who knows? So one of the other things you may want to do is, as we get closer and I help you set up your area to take the test, this may be something that you want to sticky note and have it say reaction photochemical smog or something so that you can find it really quickly. So right here are the PANs, peroxacyl nitrates. What are those? Who cares? So you just kind of need to know this in general. What do they mean by and other pollutants? There's a whole list of them. We'll get to it. All right, so this is very particular to cars. So that means that this is not a developing world problem usually, unless they have a ton of cars. This is largely a developed world problem. So how does photochemical smog affect human health? Again, you're breathing this stuff in. And when you have something like this, the NOx stuff, when this reacts with water, that forms HNO3, which is nitric acid. That is something you need to know. It is, again, not good. So it's all of the things that are associated with any sort of air pollution. You have irritation of upper respiratory system, which can lead to not always cancer. So if you have to write something down, heart attacks and strokes are always good. If you have pre-existing lung conditions, it aggravates them and makes them worse. And then also remember, if your lungs are already irritated, it makes things like bronchitis and pneumonia easier to come on in because your lungs are already kind of ripped up a little bit. Okay, so at what time of day does photochemical smog peak in concentration? All right, so let's think about this for a second. This is, let's see, down here. This says photochemical smog usually builds to peak levels by late morning. I'm going to say that it will continue to peak throughout the day because remember how big cities work. You have two major times of driving. You have the morning time drive and you have the afternoon drive. So in the morning, you're going to have a lot of car exhaust put out. So you're going to have let me see if I brought a pen. Okay, so here's your time. Okay, this is time. This is concentration. CCN is not something I made up. That's an actual shorthand for concentration. So you're going to have kind of most of these graphs, and I will show you one, show one kind of peak. In my mind, it's 2. So cars start driving, you have that NOx buildup. It's starting to get warmer, so you're going to have a buildup of that of the photochemical smog. Remember, you're not going to have it first thing in the morning because you've got to have time for that reaction to take place. And then as people come home, now this kind of dissipates a little bit, but not that much. Then as people come home, you're going to have that second buildup again. So basically, despite what your book says, late afternoon is really when you're going to have the highest concentration in the day of the actual pollution. It's going to be earlier in the day, you're going to have a bigger buildup of the initial components, later in the day for a buildup of those secondary pollutants, those secondary pollutants, the smog itself. All right, so let's see what else is in here. If photochemical smog can build up in a city from day to day, what day of the week do you think the concentration of photochemical smog will be the greatest? Think about it. You have people going to work from Monday through Friday. If the typical work week is from 8 until 5, it means you have that initial peak and then that second peak twice a day, and it builds up from Monday to Friday. Friday afternoon is when the smog is going to be the worst. Now, when is it that people are not driving all at the same time? That would be on the weekends. So that means while you still have smog, you have less people at the same time, so you have less of a buildup of that concentration, and the pollution will dissipate. So that means that you will have the least amount of pollution right before that first rush hour on Monday morning. So Sunday night is when you're going to have the least amount of pollution. In which cities is photochemical smog the most common and why? It's going to be where you have more cars. It is going to be where it is warmer. So it's one of the reasons why California has, and all of these cities here have a huge problem with photochemical smog. Now there is another reason why California has a big problem with photochemical smog, but that's going to be in some supplementary material I will go over with you in a later video. So, your book does not include the following information. The U.S. has greatly reduced the incidence of photochemical smog by requiring that all cars have catalytic converters. Look at the illustration below and note why catalytic converters reduce the incidence of photochemical smog. Alright, you need to look up what PD and PD are. That's palladium and platinum. These things, the reason this is called a catalytic converter is that these things are called catalysts. The definition of a catalyst is something that makes a reaction go faster without being used up itself. It's like how it is easier to make a sandwich on a table than it is to kind of try and assemble it in your hands straight out of the fridge. Enzymes in your body are catalysts because they take reactions that normally take days and allow them to take place in minutes or sometimes even seconds. Anyway, will you be asked about this? I have no clue. Hopefully we'll find out here soon. So this is now required to be on the tailpipes of all American cars. So normally all of this stuff is what would be emitted into the atmosphere. These are the products of combustion. So you're also going to notice that you're like, well, miss, what about the CO2? Yeah, that's in there too, but remember, carbon dioxide is not a product that is involved in photochemical smog, so that's not a concern here. Now, is carbon dioxide emission a problem? Yes, and we'll talk about that later when we talk about climate change. Okay, so here's what's coming out of the tailpipe of your car. You've got oxygen, O2, NOx, which remember is a combination of NO and NO2, carbon monoxide, that is the product of incomplete combustion, because you're not ever going to get your gas hot enough to completely burn it, and some hydrocarbons. That means that is unburned gasoline, and obviously some carbon dioxide, but we're not going to pay attention. Through a process that you don't need to understand, what is emitted instead is after it goes through the catalytic converter. So if this was not on your car, that would be there. So that means the main component of smog would be emitted from all the cars in the United States. Instead, you get this. N2. Remember, the majority of our atmosphere is atmospheric nitrogen. This is not a problem. But miss, there's nitrogen over here. Ha ha ha. That is the cool part about chemistry. The fact that it is there doesn't matter. It is the form in which it comes. All of that carbon monoxide and hydrocarbons is converted to carbon dioxide. And then those hydrogens then become water vapor. So again, because we have mandated by law that we have this in the United States on our tailpipes, we avoid a lot of the smog that we used to see before these became required. I do believe that that is the end of our little photochemical smog section, so you're done.